Of course, I'm going to discuss all of the three questions before we go to chapter 4. Okay, so basically later we will be going to chapter 4. And okay, so before that, let's go to chapter 2 and then the three questions. Okay, so again, you can use Desmos to see the answers for this one. Okay, well, basically for number 1, you need to solve the 2 points or the 2 intersection points that these 2 equations will be intersecting. Okay, x plus 2y equals 5, and then 2x plus y equals 2xy. All right. Um, okay. So I wrote some steps here that might help you in the future. Okay. So first, you choose the linear equation. So the linear equation is the one without any exponents or indices. So it's just x plus 2y equals 5. This is the linear. Now, this is the non-linear because this will create a curve instead of a line. Okay. You can use Desmos if you want to see it right away. All right, so what do we do with this linear equation? Um, we will just express this in terms of y, or in other words, we will just make x the subject of the formula. All right, so that's what I did here. So x is equal to 5 minus 2y. All right, so after this, after you have done this, we go to the second or to the other equation, which is 2x plus y equals 2xy. And then we substitute this to the value of x. So here and here. I saw some homeworks wherein you just substituted your x value here only once. Take note that you have two x's here, two variable x. So you need to do it twice. That's why this is what I got. Okay. So from 2x, it became 2 times 5 minus 2y. Of course, it came from here. And then you bring down y. And then from here, 2xy, meaning 2. And then x there becomes x 5 minus 2y here. And then you still have this y. So you have to bring that down there. All right. So this is what we got right now. So how do we simplify this? Of course, this one, you just need to distribute it like that, right? And then you'll get 10 minus 4y, bring down y, and then this one, okay, let me zoom in a little bit. Okay, so 2 times 5 times y, you'll get 10y, all right? Now, if you're confused with this, you can write this like this one. So 2y times 5 minus 2y. It's just the same thing, class. All right. Okay, so again, 2 times 5 times y is 10y, and then 2 times negative 2y is negative 4y, but then you still have y here. That's why it became, or it becomes negative 4y squared. Okay, that's what happened there. So here, any question on this part? All right, no question on this part. Okay, so let's continue. And then what's after this? After this one, you need to change this into the standard form. The standard form is wherein ax squared plus bx plus c. So that's what I did. So I have negative 4y here. Put it to the left side. So it becomes 4y squared. And then 10y, transpose it to the left side. You'll have negative 4 plus 1 minus 10. It'll give you negative 13y. And then bring down 10. And then everything is equal to 0. So this is the standard form. Okay. And then after this, it's up to you if you want to use factorization, completing the square, or quadratic formula. So for me, I'll just use quadratic formula because it's much faster and easier, and it may take a while to factorize this because it has a coefficient over here. All right. So anyway, so a, b, and c are 4, negative 13, and 10. So using the quadratic formula, so this is negative b plus minus b squared minus 4ac, of course don't forget the root sign, divided by 2 times a. So I just substituted all the numbers here. Okay, please be guided. And then so this is now positive 13 plus minus. When you simplify this, you'll get 9. So it's the square root of a perfect number, perfect square number, and then divided by 8. So what is the square root of 9? It's positive and negative 3. Okay, so we separate the plus and minus. Therefore, the values of y is 2 or 1.25. Okay, do you guys have any questions on the first step? Okay, on this part here. Okay, maybe some are asking, Mr. You did use the quadratic formula, right? But how come this is y? It is usually x, right? Okay, but you can use any letter here. It depends on what variable you are solving for. In this case, we are solving for y. That's why this is y and not x. Okay, so that means if we have the values for y, we need to find for the values of x this time. It's like the opposite one. Okay, all right, so we have y. So what is x? So when y is 2 and then y is 1.25, what is x? So where did I get this formula? Again, it came from the beginning. It came from here. So x is equal to 5 minus 2y. So 5 minus 2 times 2 is equal to 1. So my first point is at 1, comma 2. Okay, and then my second point is at 1.25, and then what is x? X is 2.5. So my second point is at 2.5, comma 1.25. So this is where these two equations here will intersect. Okay, any question, class? Sec 3. All right, so no question. All right, and then number 5. So number 5, this is pretty much simpler compared to number 1. Okay, so again, it's now a sentence instead of just equations. So find the coordinates of the points of intersection of the line x plus 2y equals 10. So this is the linear, and the curve 2y squared minus 7y plus x equals 0. So basically, this is the curve, and then this is the linear formula or equation. So first things first, the first step is to choose the linear equation. Okay, so that's what I did. And then I see x here. So I'll just make x the subject of the equation. So x equals 10 minus 2y. All right, so that's what I did. And then after this, you go to the next or to the other equation, which is this one, and then substitute this in place of x, in place of this. All right. So that's what I did. So bring down this, and then x becomes 10 minus 2y, then equals 0. Okay, so simplify this. So you get bring down 2y squared, and then negative 7 minus 2y is negative 9y. Then bring down 10 equals 0. So this is what you have now. So this is already quadratic equation. So how will you solve this? So again, obviously, I use the quadratic formula. Okay, quadratic formula. So a is 2, b is negative 9, c is 10. And then using the quadratic formula, so this is how my formula looks like. Okay, so please try to use the formula more often. Okay, because you won't be given the formula when you take your test. Okay, anyway, so that's it with everything inside now. So this is 9, positive 9, and then when you evaluate this, it is the square root of 1, then over 4. Okay, now what is the square root of 1? 1 is a perfect square number. So the square root of 1 is simply positive 1 and negative 1. So simplifying this, your y values are 2.5 or 2. Okay, so that's it. So 2.5 and 2. And then for your x values, so again, you will have two x values since you have two y values. So if when y is 2.5, what is x? X is equal to 5. Okay. And then when y is 2, x is equal to 6. So therefore, your points of intersections are 5 comma 2.5 and 6 comma 2. So yeah, those are your 2 points. Okay, any question, class, for number 5? Hmm? Okay, none? Okay, so class, by the way, if you whenever you see letter C, that means that this question already appeared in the exam, in one of the exams from IGCSE. All right, so yeah. Okay, so that's number 5. And then for number 7 is, it looks hard, but actually it's not um, if you try to recall what we have did or what we did last time, because there was an example like this, right? Okay, anyway, let's have number 7. So number 7 was optional. Number 7, if 2, 1 or 2 comma 1 is a solution of the simultaneous equations x squared plus xy plus ay equals b, and then 2ax plus 3y equals b. So these are your simultaneous equations. Find the value of a and of b. Find also the other solution. Okay, so for this, 2, 1 is a solution. That means x is to 2, y is equal to 1. All right. And then what should we do to solve for a and b? So basically, class, all the x and y's here becomes 2 and 1. It's just that. So I'll use red for my first equation and then blue for my second equation. All right, so let's go first with the first equation. So you have this, and then replace x with 2, and then replace y with 1. So this is 2 times 1, because x times y. And then ay is just a, because we don't write 1, right? So it's just a instead of 1a, equals b. So simplifying this, you'll get a minus b equals negative 6. All right? And then for the second equation, so you have 2ax plus 3y equals b. So x here becomes 2, y becomes 1. Okay, so and then simplify this, you'll get 4a minus b equals negative 3. Now, basically, you have 2 equations. So for this, I'll just use elimination method because it's much faster. Okay, since I have negative b and another negative b here, I'll just make my second b a positive b. So I have opposites. So what I did is multiply this by negative 1. So that's what I got here. Okay, so instead of this, I got negative 4a plus b equals equals 3. And then bring down the first equation. So this is eliminated, right? So a minus 4a is negative 3a, and then negative 6 plus 3 is negative 3. So therefore, a is equal to 1. Okay, and then b here, you just choose whether this or this one. Okay, so a minus b is equal to negative 6. So therefore, b is equal to 7. All right, so that's it for number 7. Okay, so guys, do you have any questions before we go to chapter 4? Okay, none, no question. Okay, now okay, so if you have your textbooks, please go and get your textbooks. Let's jump to chapter 4. Chapter 4 is about quadratic expressions and equations. So basically, class, we already had this back in e-maths. You had a test about this one. But of course, this is additional math, so it's a much deeper understanding of the concept about quadratic expressions and equations. Okay, so if you have your book, page 61. For those who doesn't have the book yet, I'm going to send you a file, but I'll send it after I have discussed some examples, because I haven't sorted my files yet. Okay. Okay, so that's it. Let's go to chapter 4 now, quadratic expressions and equations. Now, let's listen. Um, in e-maths, you have learned or maybe we have encountered the word maximum and minimum point, right? So it's the same thing as maximum and minimum value. Given a quadratic equation class, this one, the minimum and maximum value or maximum points are are the turning point in a quadratic graph. Okay, for example, if this is your graph, so that means that the highest point on this curve is the maximum point. It's the tip. It's where, let's say this is a basketball. So if you throw a basketball, this is the uh, pinnacle or the highest point the ball can make before it goes down. All right. So same concept here, class. So the maximum or even the minimum point are the tips or the turning points of your quadratic graph. Okay, and then of course, um, you have the different parts. You have the x-intercepts, the y-intercept, and what is this line again? It is the line of symmetry. But now, we are going to apply this with different quadratic equations, particularly completing the square. All right. So please turn your books on page 62. Okay, page 62. If you don't have it, just look at your screens. I have prepared this for everyone. Okay. Now, so here, I made an outline here, class. This is for you guys, okay? So you don't have to um, read everything like this, okay? Now, basically, class, the question here is, how can we graph a quadratic equation like this given a quadratic equation in completed square form, or when we did the completing the square? All right, because um, by doing the completing the square method, it will show us the minimum and maximum value of a quadratic equation. Meaning, it will show us already the parts that we need in order for us to graph this curve. Okay, so please bear with me. So I'll give you guys one example here. So again, um, by completing the square, this is the format, right? This one. So a times x minus h and then squared plus k. So from this example here, the example here is this: y equals 2 times x minus 2 squared plus 3. Okay. So how do we break down the parts? So this number here is your a. Okay, that's your a. And then this number here is your h. And then this number here is your k. Those are the three numbers that you need to identify. Okay, that you need to look for in a completed square form. Okay, now what's the use of this a, h, and k? What's the use of those in graphing this quadratic equation? Okay, so this is where my notes comes in. Okay, so the a, actually your main concern with a is just you need to know if it's positive or negative. Only that, class. Because if it's positive, the graph is happy. Just like this one. 2 is positive, therefore, your graph is like this. It's a happy graph. Right? Now, if this turns out to be negative 2, it will go upside down. Alright, so let's go to Desmos to see how it works. Okay, so look here. So this is the graph, right? So this is the graph for my first example. Okay, so notice here, class, that 2 is positive, right? If I turn that into negative 2, look what will happen with the graph. Okay, so if that's negative 2, see what happened? It went the other way. So your main concern for A is just whether it's positive or negative. So when you draw your graph, it is much easier for you to identify if it's opening upwards or downwards, or in other words, if it's happy or sad. Okay. Again, if it's positive, it's happy. If it's a -2, it's a sad graph, right? Okay, so that's it for A. Now, how about this H and K? So what is H? Hmm? Okay, right. What is H? H tells the x-coordinate of the minimum or maximum point. Okay, so look here, class. Look at the minimum point. So the minimum points, H value is, or the x-coordinate is 2, because this is 2. Okay, and what else? So the H also tells us the equation of the line of symmetry. So this is the line of symmetry, class. Okay, all right. So that's the use of H here. So knowing this gives you the x-coordinate of the minimum point or the maximum point, and then it also tells you the equation of the line of symmetry. For example, if this turns out to be 4, this is now 4 and 3, and then your x is equal to 4. Okay, so you follow this. Now, class, listen. If this is -2, your x-coordinate is positive. Okay, what if this is +2 or +2? What will happen? Hmm? Okay, so let's change that +2, sorry, that -2 into +2. So I'll remove the -2 and then let's change it and let's make it +2. So what happened? So your graph shifted to the left, right? What does it mean? That means that your x here becomes -2. Okay, so the standard form is that it should be minus to make it +2. All right, so whenever you see x -2, that means that your x coordinate is a positive. Okay, so this one is 2. If this is 2, this is +2. And also, it affects your line of symmetry. Okay, and then how about for k? K is basically the y coordinate of the minimum and maximum point. If this is 3, that means that this is also 3. Okay, so those are the important parts, class. And nothing more, nothing less. It's the only purpose of k to tell the y coordinate of the minimum or maximum point. And then of course, we have this. It's the y intercept. Now, in this one, in A maths, how do we get the y-intercept? Of course, there are two ways. Now, in A maths, there is now a formula. AH squared plus K. Okay, so that's your formula. Now, if this is 11, that means, okay, so what is A? So this is equal to 2 times, what is H? H is 2 squared plus 3. When you simplify this, you will get 11 as your answer. And that is your y-intercept. Now, if you cannot remember this formula, you can just make x equals 0. For example, you're given this equation, right? So to know the y-intercept, you just change x and make it 0. And then you will get y is equal to 11 as your y-intercept. Okay, so there are two ways in getting the y-intercept. Okay, so basically that's it, class. So again, whenever you're given an equation in completed the square form, identify A, H, K, and then also the y-intercept. Those are the 4 important parts in graphing a quadratic equation. Okay, so do you guys have any question? And then of course, class, once you have your 3 points, you should learn how to graph this one. Okay, and so I suggest that you use a pencil for drawing your graph. Okay, so that's it for our first example. All right, now let's have another equation, a different one. Okay, so you guys can see. You can turn to page 63. Okay, so this is another example. This is still in completed the square form. This is the equation here. Okay, so let's break down. So if this is the given from there. Okay, Okay. By the way, class, don't be confused if 6 is over here. If you're confused, you just move it behind the -2x plus 1 squared plus 6. It's just the same thing. Okay. If you're confused, you can do it like this. All right. If you want to follow the format here, because this is the format, right? K is supposed to be here, but in that second example, it was in front of it's in front of this. Okay, but it's just the same thing. All right. So anyway, okay. So how can we identify the parts? So we are given this one. So this will be the question, class. You will be given an equation like this or a different one. So what is A, H, and K? So A here is -2, right, guys? So that means that your graph is sad. That's why look at the graph. It is sad. Okay. Again, for A, what we're after is just the positive and the negative. Okay, we don't need the number. We just want to know if it's positive or negative. So we know how to draw the graph. Okay. And then, okay, so we're done with A. How about H? What is H? Since this is +1, that means that, okay, in the format x minus h, okay, if you're confused, let's just write the standard form again. So y is equal to, um, so a times x minus h squared plus k. All right, so this is +1. So that means that 1 is, or sorry, that h is -1. Okay, so this is the standard form. Okay, so if it's +1, that means h is -1. All right, and then what is k? K is 6. This is 6. Yeah, k is 6. All right, so that means that the coordinates of your maximum point is at -1 and 6. All right, that means that's the tip of your curve. So if your curve is a sad curve, that means that the tip is -1 and 6. And then that's, yeah, so you need to graph that, class. All right, -1 and 6. Okay, and then what is the last part that you need to know? The y-intercept, right? So you can use this formula, ah squared plus k, and then you will get 4 as your y-intercept. Or you can just make x 0, and then you will still get +4 as your y-intercept. Okay, so that's why the graph intersected the y-axis at +4 here. Okay, and then the line of symmetry, x is equal to -1. So class, if the line of symmetry is being asked, or you need to show the line of symmetry, it's always equal to what is h. Okay, x is equal to -1 because h is equal to -1. Okay, so those are the key things that you need to know in drawing your uh, curve like this. All right, and then after you have drawn your curve, don't forget to write the equation. Okay, you don't forget to write this beside the curve. All right. Okay, so that's it. Okay. So again, you need to identify AHK, the y-intercept, and the line of symmetry. Okay. So let's have an actual example that we need to solve. All right. By the way, class, do you have any questions? All right. I'm going to send my slides. Everything, I'm going to send it in the group. Okay. All right. Okay, wait. Let's have some example first. Okay. So let's go to number 2. All right. Do you have your books? Okay. So let's answer letter A and letter B. Okay. Can you guys please okay, let's do this. Let's do letter A first together. All right.
Is it
So
the A math book, sir?
yes, A maths. This is the A maths book. Yep. Page 67. Okay. Page 67. Let's try to do number 2, letter A, and letter B because it's similar from the first two examples. Okay, so wait, let me just copy this then I'll put this in my slides. All right, because these are complicated examples, not very complicated, but they're different from my set of examples. Okay, wait. All right, so again, on number 2, you need to state the minimum or maximum value. By the way, the maximum, the minimum or maximum value is just the same thing as minimum or maximum point. They're just the same thing. Okay, so when I say point, it's just the same with a minimum or maximum value. And the corresponding value of x. Hence, sketch the curve indicating the y-intercept. So it's everything that we have just discussed from this example here. Okay, so let's go with letter A. Okay, so letter A, let me write the question again. Okay, so it's y equals 2 times x minus 3 squared plus 1. So what is my A? What is my A? A is what? I'm not writing the standard form yet. So you guys identify. So A is what? Is it 2, 3, or 1?
2.
Anyone? Okay, it's 2. All right. So A is what? A is positive, right? So if it's positive, that means my graph is, okay, happy, right? My graph is opening like this. It's a happy graph, right? All right. How about H? What is H? 3 or 1? What is H? 3 or 1?
1.
Hmm?
Wait, sorry.
H is 3.
3.
Okay. And then K is your 1. All right. So that means that the coordinate of your um, minimum point is at what? What's the coordinate? So it's 3, comma 1. So you have the coordinates now. So you have the tip of the curve now. All right. So what else do we need to identify? So we also need to find the y-intercept. So how do we get the y-intercept? So there's a formula again, right? Do you remember the formula? The formula is a h squared plus k. All right. So what is a? A is 2. H is what? 3 squared plus k is 1. So what is the y-intercept? Your y-intercept is, so 19. Is it 19? Hmm? So 9 times 2 plus 1. All right. It's 19. All right. And then what is your x? Sorry. What is your line of symmetry? Hmm? What is your line of symmetry? X equals what? Again, the line of symmetry is equal to whatever h is. So if this is 3, your line of symmetry is also 3. Okay? So they're the same. Okay, wait. So they're the same class. So x is equal to 3. So again, if this is 3, your line of symmetry is also 3. All right. So we have identified the parts. Now, how do we draw this graph now? Okay. By the way, class, maybe some of you are wondering, how you determine if it's minimum or maximum point? Of course, if your graph is happy, that means it's like this, right? So the tip is your minimum point, right? It's minimum point. Now, if your graph is sad, of course, it's like this. That means that the tip is a maximum point, okay? So that's how you determine if it's minimum or maximum point, if it's up there or below the curve. All right, so how do we draw this? Okay, you don't have to use graph paper here. So just make a rough sketch, okay, indicating all coordinates given there. So again, you start with the tip or the minimum point 3, 1. So let me just 1, 2, 3. And then where's 1? So here's 1. So the minimum point is over here. Okay, so this is where the minimum point is 3, 1. All right, and then what's next? Y-intercept 19, positive 19. So therefore, I should extend my line here over here. Not too much. You don't have to do it like very precise. Okay, so this is y, this is x. Okay, so let's say this is 19. Okay, so that's 19, right? Okay, so like that. So this is where your y-intercept is, right? This one. Again, this is your minimum point. Okay, so what do we need to do next? Okay, now to help you draw the curve smoothly or properly, try to draw the line of symmetry. The line of symmetry is always a vertical line. Okay, so let me draw the line of symmetry. So this is the line of symmetry. Okay, this is where x is equal to 3. Now, what is the purpose of the line of symmetry? That means, okay, because symmetry, from the word symmetrical, whatever is on the left is balanced or reflected to the right side. So that means if I'm going to graph this one from the y-intercept to this, all right, that means the other side is just a reflection of this. So that's the purpose of the line of symmetry. Okay, to make the graph balance. All right, so let me just redraw my graph. I know it's not the okay. So here, so all right. So you draw half. So to complete the other half, you just try to reflect this part. Okay, so try to reflect this one. Okay, so let's try to reflect it. Okay, so all right. So at least it's like that. So that's it. So that's your graph, class. Okay, and then don't forget to write the equation. So equation is y equals 2 times x minus 3 squared plus 1. So that's it. So that's how you draw your graph. All right. Again, class, just make sure to balance this out. I know my graph is not that perfect, but okay, at least make it similar as possible with this one. And take note, class, don't make a tip. There's no corner here. It's supposed to be a smooth curve like that. Okay. This is my graph for letter B. So is yours like this, guys? Okay, so let me explain again letter B. So this is letter B. So we're given y is equal to 4 minus x minus 2 squared. So a is negative 1 because this is 1 here, right? So that means that my a is negative. That means that my graph is sad. So it's like this. Okay, so it's sad. It's a sad face. And then h is 2 from here. And then k is equal to 4. This one. All right, so that means that my maximum point is at 2 comma 4. All right, so this is where my or the tip of the curve is. Since it's a sad graph, it's maximum point, right? And then how can I find my y-intercept? You can use the formula ah squared plus k. Or if you don't, if you cannot remember this, you just make x here a 0 and then solve the equation. So it will give you 0 again. So anyway, the y-intercept is at 0. Okay, so that's why this is 0 here. Okay, and then the line of symmetry is x equals 2. So this is equal to whatever h is. So if h is 2, x or the line of symmetry is equal to 2 also. Okay, so that's it. Okay, so how do we draw this? So start with the maximum point. Locate this. So here is 2, 4. Okay, and then locate the y-intercept, which is 0. And then draw the line of symmetry, which is in the middle of the curve, right? And then try to draw half of the curve from here, from the y-intercept up to the maximum point. And then you can stop here. And then you just reflect this side to the other side like that. Okay. And then that's how you complete your graph. And don't forget to write the coordinates of the maximum point and the equation of the curve. And that's it for letter B.